Very good evening to all of you. Am I audible? Can you just confirm in the chat, folks? Okay, let me see some responses. Okay, thanks, Shabana. Thanks, Monisha. Good evening, Shruti, Rubin. Okay, all right. Thanks, Shruti, for confirming. Good evening, Pragya. So let us always wait for a few minutes before we have folks joining in. Good evening, Nawab. Good evening, Ankush. See, people are connecting in now. Good evening, Shakshi. Good evening, Sai, Anudeep. We just hit 7 now. We'll wait for another 4-5 minutes. Is my screen visible to all of you? Can you just confirm? All right. Thanks, Zaid, Meher, Monica for confirming. Shruti. Thanks, Balaji, Anisha. Okay. You see, many of you are logging in right now. I could see Vivek, Mohan, Sonal. Very good evening, all of you. Today is a different topic, right? Yesterday we met in the Disha session. Many of you, I guess, we are meeting in a different context. We have some new folks joining in. Sagita, Banu, Meher. We have Sashmita joining, Meher joining. Good evening, folks. couple of more minutes, then we'll get started. We always give that 5 minutes grace time for people to dial in, get adjusted. Good evening, Priyanshu, Darshan. Meher, yeah, good evening. Good evening, Hiresh, Vaishnavi. This is the first session. This is only one session, Vaishali, for webinar, external webinars with the external speakers, right? Good evening, Vinay, Pratiksha. Good to see all of you. Samyukta. All right, I think we are just about time. Let us get started. We'll do some warm up by the time more folks are dialing in. Very warm welcome to all of you for the second Masterclass webinar. So today we have a very interesting topic about artificial intelligence and machine learning. So before I start, I always have two quick questions. One, from which place you are joining this webinar? Can you just type the town or the city where you are joining this call? So we see the distribution. You can see people from Maharashtra, Bangalore, Satara, Chennai, Shirdi, Kanyakumari, all the way down, Guwahati, all the way east, Kolhapur, Kenya. We have people abroad, students, Junagadh, Bangalore, Vizag, Satara, Mysore, Bangalore, Ahmednagar, Viluppuram, Kenya, Kerala, Pune, Tirupattur, Chennai, Tumkur, Nainital, Jaffna, Sri Lanka, Prayagraj, Salem, Madurai, Pune, Tumkur, Bangalore, right? I couldn't see the names, right? So pretty much we have, you can see people joining from Assam, right? Chennai, right? You can see all the way from what I call Kanyakumari to way east, Guwahati, way west in Pune, right? So we have people joining in, and we have people who are joining outside India. Many of our international interns, they're all based out of Kenya. I could see many of them joining in. So thank you very much for all of you to joining in. And one more question before we start. Can you just type, are you a student in Emertxe, or are you a intern, present or past intern, or you are a newbie, right? Can you just type so that I get a distribution? Just a quick view. Present or past student or a newbie. Okay, we could see some present intern, newbie, student, present intern. We could see some newbies also coming in, good number of them. Glad to see that. Ex-student, present intern, student, present student, current student, student, right? Good distribution, present intern, yeah, present student. Great. We have a very good distribution right now. So thank you very much. I think it's about time that we get started with our masterclass webinar series. Like always, let me open the conversation, set the context, introduce our speaker, and then I'll go off the video. Then we have the speaker, Mr. Jidu, to take over the webinar today. Okay. So once again, very warm welcome to all of you. So today we are doing our second webinar in our masterclass webinar series. We started this, we restarted this initiative sometime in last month, because I said pre-pandemic we used to have expert people coming into our office and delivering these webinars, which has changed due to pandemic. Having said that, the power of internet and webinar, it makes us connect all over the India, across the world, right? We have people joining from various cities, places. So that's amazing to see. And one more thing, after the last webinar, our team has further improvised, and then they felt like, we can just kind of themed it, something like a Netflix series or something like that. We'll make it like a series of webinars. So we decided to call these webinars, right, last one and this one and some more coming up, we would call it as an emerging tech series, where we'll strictly talk about the technology aspect of it, and then some more topics have been planned in the soft skill side, leadership, and many other topics, and even some of the coding boot camps and stuff like that, right? So there are various categories we are going to do this webinar. So this series we talk about as a emerging tech series. So edition 1 and webinar 2 they are hosting on 5th of March. And people who are new to Emertxe, let me briefly introduce in a couple of slides about Emertxe. Emertxe is a tech company. We have been in this segment for the past 18 plus years. So what we do as an organization, we do training programs in 3 technologies: embedded systems, IoT, and full stack development, web development, targeting to 2 segments. One is what we call an employability, where we train entry-level engineers to become job ready. And as you know, India has become a country which is churning out a lot of engineers who have aspirations to do well in their careers, but unfortunately, they don't have the necessary skills to get into those jobs, especially in areas like embedded systems, IoT, or full stack web development. So we provide them with 6 months immersive training programs, pretty much hands-on. Make it experience-based learning, typical to the image what is there, pot making, right? You are kind of do things in a hands-on manner and make yourself employable, right? The second set of segment where what we do is called upskilling segment, where people who are already having some work experience, but they wanted to get into the core, or the embedded side of industry, right? They would have got some jobs. They'll be working in domains like, for example, IT or some kind of support or sales and marketing, different functions. But they would have gone far away from their engineering core, right? They want to come back and upskill themselves and move forward. So we help to do upskilling programs. And also today, as you all know, people and their skill plays the most important differentiator in the market. So which means to say we offer customized corporate training programs where companies come to us and ask about training programs, where we train people anywhere in the range of entry level graduates all the way up to people who are having about 15 years of experience. So that's what we do, Emertxe as an organization. Our leadership team, 3 of us are part of the team. We have Mr. Maz, who is a managing director and founder of the organization. He should be in the call, and myself, I'm one of the directors in the organization. And we have Mr. Mubin, who is the technology head, mainly looking into the training delivery. He leads a team of mentors. So 3 of us are part of the leadership team in Emertxe. And placement companies wise, as I told, employability remains our focus, where we have companies mainly working in the core segment, which includes, for example, automotive, aeronautics, semiconductors, consumer electronics, and even for that matter, companies who are working the service segment, but they're providing embedded services. For example, companies like Tech Mahindra, L&T, they hire our students. So these are all the set of placement companies. I think many of our Emertxe students and interns know that. We keep them posted, and this has been a dream run we are having in the year 2022, where in January and February both, we have 100 plus companies hiring our students. So this has been a phenomenal year for the job market, where there is a lot of skill demand for embedded systems engineers, be it a startup, mid-sized company, or a big company, right? So some of the companies are provided in this particular screen, and tons of them, more than what is mentioned in this particular screen. So they continue to hire our trained students who are getting trained in the areas of embedded systems, IoT, right? And kind of full stack webinar, we kind of paused it. We would like to restart shortly, right? Okay, all right. Let us come to today's agenda about why these webinars, right? I already introduced, but let me reiterate for the sake of people who are joining newly. So I would say there are 2 M's are the reasons behind these webinars, because as an entry-level engineer, whether you are our student or you are an intern with us or you are joining this webinar newly, right? So what we found broadly is the lack of mentoring in the academic ecosystem, right? And there is a huge disconnect between what and how a particular technology has been applied versus how we are learning theoretically in the college, right? So we decided that as a team of Emertxe, right, we would invite experts from the industry who are working in that particular area, come and share their experiences and give you the real happening, what is the upcoming trend and where the technology is heading, how you can build skills in that particular area so that you can achieve your dream, right? So when the right set of mentoring happens in form of these webinars, so what we result in motivation, right? As engineers, you always wanted to hear from somebody who's been there, done that. Also, really want to know how this particular thing gets applied, especially if you talk about today's topic, right? It's all over the place, right? Machine learning and artificial intelligence, everybody talks about it, right? How it's getting applied and what are the use cases and how the tech is going to going forward, how the technology is going to change. So that will be the focus of today's webinar, right? So that's the two M's which you talk about: mentoring and motivation. Okay. So let me quickly talk about today's webinar. As you all know, the topic is about artificial intelligence and machine learning. Just let me add a couple of points what I know, then we have expert speaker who will be sharing the real thing for today's webinar, right? Artificial intelligence, machine learning is pretty much in all the domains. You name finance, or you name medical, or you name automotive, or you name consumer electronics. Everything that you can think of being touched by artificial intelligence and machine learning, right? It's very broad in nature. In fact, it sometimes becomes overwhelming for all of us to understand. In fact, even in our webinars, which we use, our monthly meetings, and even our discussions happens inside the Emertxe, always students wanted to know, are curious to know who this AI ML is shaping up, one thing, right? Then the second thing that today's topic is about, in edge computing. So some of you would have heard about this topic, but some of you may not be. So that will be the context of today's topic: AI ML applied in the edge computing, right? So that there is a benefit called full autonomy can be achieved, right? So what do you mean by edge computing? What is full autonomy? That's what our expert speaker, Mr. Jiddu, is going to talk about today. And this particular webinar is planned about 2 hours, and all the participants, just to ensure that we all get enough motivation, we will be sending you the participant certificates for people who are in this particular webinar. And by the end of webinar, once our expert Mr. Jiddu Mohan completes his talk, I'll again take over, and then I will talk about the quiz for today. And for this quiz, I'll be sharing a code, something like a coupon code, and then our quiz will be live in our Instagram page around 9 p.m. We'll make it live. So why this particular code? Because we have so many thousands of followers. We don't want them to take the quiz, right? And then luckily win a prize. We want only people who are attending this webinar who will get this particular coupon code, or the quiz code, so that you can put, and then we evaluate only students who are putting the right coupon code. So people who win, our team will assess in the next week, and goodies will reach you. Last time, we shipped goodies to, I think, about 10 winners in the last quiz, and we do have plans to increase the number of winners this quiz. And we received a lot of feedback. People said both, the topic, how it was delivered, and also the certificate and the goodies part, right? So we received a lot of feedback, positive feedback from all the participants. So we expect the same today, and that too, given the topic like AML, we really expect you to actively participate till the end, right? And as far as the questions are concerned, you keep typing in the window. So what I will do is I'll also be a listener. I also will take notes as a part of today's webinar, right? Once I collate certain set of questions, we'll pause Mr. Jiddu, and then we can I'll summarize your question to him, because he can't see the question. I can see the question, and then he can answer the question, and then we can move on. So that will be the modality, like how we had done the last time. Okay. So with this note, let me quickly introduce our speaker today. He's a researcher who loves building solutions that makes products and services intelligent, right? Today's world is all about smart or becoming intelligent. So you would like to build solutions that makes products and services intelligent, right? So actually, he comes from a multidisciplinary experience. So pretty much, almost all the areas what we talk about, machine learning and AI, which includes industrial AI, deep learning, machine learning, reinforcement learning, natural language processing, knowledge graphs, predictive modeling, time series forecasting. So these are all various elements of, or various domains of subdomains of AI and ML. You will talk further on this. Okay. And he has overall about 10 years of experience, completely working in the corporate research and innovation divisions. So because when you talk about corporate research, unlike a typical development work or testing and release work, what happens in many of companies, we really found Jiddu's profile very unique, where he has been working corporate research divisions, where their goal is to investigate, do research about the futuristic technologies, so that they can build their product or solutions as they move forward. So that's completely the more of an domain or the experience that Jiddu comes from, and is currently working in Siemens as an expert AI/ML researcher in the data analytics and AI research group. And before that, he worked for 7 years in Robert Bosch Innovation Division, and he already has 4 patents filed in his name. And Mr. Jiddu holds a master's from National Institute of Technology, Karnataka. Okay, so we would like to welcome. First of all, we'd like to thank Jiddu for accepting our invitation, taking time off. As you know, Saturday evenings everybody wants to spend time with their friends and family. He immediately accepted our invitation, and he is really passionate about sharing his knowledge. He's been invited speaker in many conferences, so immediately accepted, and he's also came up with a very wonderful topic. Not only that, I understand that he is having a demo to showcase some of the examples that is going to showcase you. So please do not miss this wonderful opportunity. As always in Emertxe, we say no question is a stupid question, no question is a wrong question. Please ask as much questions as you can. Keep typing in the window, and then I will play the role of a moderator, and then ask the question to our speaker, Mr. Jiddu. Right. With this note, let me invite Mr. Jiddu. Can you speak?
Yeah, sure.
Okay.
Hello, guys.
So that is Mr. Jiddu. Let me go.
Okay.
Let me just share. Let go of the camera. 1 minute. Let me make you a presenter.
Okay. Yeah, perfect. I think you'll be able to see my screen now. Okay.
Yeah. Yeah. So
okay.
I will go off the video with you and all the students, interns, and newbies. I will go off the video. I'll be a listener. I'm also very eager to learn, and my whole Emertxe team is also here. Good number of them. So let us use it as a very good learning opportunity. Warm welcome, Jiddu. Over to you. Probably I'll take over from you once you are done. So thank you very much. Over.
Yeah.
Thank you.
Yeah, thank you very much. Thanks to Emertxe for inviting me for this particular topic, and I'm really interested to interact with you, even though this is maybe a one-sided interaction. So I really appreciate you typing your questions as I said. So he will actually read out the questions for me, and then I will be able to interact with you in this particular manner. Intelligent edge or AI ML in edge is a very, very hot topic now, and it'll be interesting for you if you are able to maybe upskill in this particular lines also, so that you increase your competency and also your employability when you face any interview. So with that, maybe I will go to today's agenda. Okay, brief intro about myself. Already it is done, so I'm not going mainly into what I'm doing, and specifically I'm interested in industrial AI and explainable AI, which is what I'm actually working for past 1 decade. So I hold some positions as voluntary positions as a board of members to a couple of colleges, and that is fairly out of my interest, and definitely they also invited me for that. But yeah, I always want to interact with you guys, those who are coming into corporate, so that this transition from the campus to corporate is actually a smooth one. Yeah, with that, this is what will be today's agenda. Either directly or indirectly, some of the things will be directly thought or will be discussed here. Some of the things will be indirect also. So one of the important thing is the edge computing itself, and then what is actually data-driven intelligence, how AI ML is actually playing an important role now. I will not go into mainly how to build AI ML models or generally what is the specific libraries that we are going to use in AI ML itself and all. These things will be something which will take a lot of time, and we have 1.5 hours, and we will specifically discuss on how these technologies, AI ML technologies, and the advent of this particular new paradigm, edge intelligence, is actually changing the industry, and how you can actually get benefit out of it by upskilling yourself towards this. So, and what is autonomy and autonomous system? What we will be actually discussing will be mainly on the autonomous system, which is enabled by the edge intelligence, and how we can actually go towards a full autonomy. Um, many of the videos and all will be too fancy to show you the full autonomy. But when you, in reality, to ship a full autonomous system or deploy a full autonomous system, it's not that trivial. It's quite difficult to have a decision-making engine which is actually serving you with a full autonomy. I hope I would also will be able to show some lights on in this particular direction. What is the complexity related to that and all, and what is the need of edge intelligence itself? Because why it is actually, whether it is a push that new technologies are coming and it is actually becoming so fancy and everybody's interested in intelligent edge, or is it like a pull from the industry? Is it the need that industry is actually having so that it is actually driving towards this direction? We'll talk on that also, and definitely the technology stack, because all of you will be interesting on to understand, let's say, if you want to build something in this particular direction, where you can actually start and how you can build, and what is the important things that you should have in this particular direction. I will actually take you. And some of the relevant use cases. There are some limited use cases which I have will be introducing, because there is exhaustive number of use cases, as you know, for the edge intelligence. So once the technology stack is over, you will be able to understand that how any of the application that you are seeing at this point of time can be migrated to edge intelligence case, and then how this will be very, very interesting. And some of the challenges, and what is the career prospects and Q&A. So specifically this Q&A, it will be better that at least once in 15 minutes, somebody stop me, and then we can have this Q&A. And otherwise, at the end, if you keep the questions till the end, maybe I will be missing what you are actually inferring from this, or what is your understanding in this particular context. So whether I'm actually going over your head, or whether is it something that you already understand, then I can actually skip later this particular some of the contents also. So with that, let's go directly jump into the topic. And the take, please.
Friends, folks, please feel free to type the questions. Is that fine? Can you get some responses? Keep typing. You don't need to wait. As and when the slides are running, I already see a couple of questions are coming. Keep typing. As Mr. Jitu said, I'll pause in 15 minutes or so, and then I'll moderate, and he can answer the questions. So feel free to type. We really appreciate. Yeah. Thank you, Jitu. Proceed. Yeah.
Okay. Yeah. So mainly the takeaways will be how you what is actually edge computing and AI ML on edge, and the technology stack of it, and what is the opportunities, and what are some of the use cases, specifically how you will be able to start a specific project in that you are going to do maybe in a coming month or coming weeks. And that will actually be great. At least maybe a 5% of the colleagues who is able to, I am able to motivate in this particular direction. I think that actually will be great for me to get a satisfaction that, yeah, this time spent here with you interaction is actually very much fruitful. I know that this interaction is already fruitful, but it will be very interesting if you are able to maybe host some of the code in the Git, and then maybe send me some links also in this, or maybe post in the forums that you have. So that social media forums where you have the projects that you are doing in this direction, with the motivation that you are taking away from this webinar. Okay, so the first question will be definitely, what is edge computing? Edge, I think most of you might have at least heard about edge computing. It is not something very new. A lot of edge computing applications you might have seen, or you might have worked on these specific applications. So let's see what is a computing. So let's say we have to make some decision at any point of time on from the sensors which is actually connected, because machine has to understand your surroundings to make some decision, whether it is through some specific sensors or the temperature sensors, or maybe vibration sensors, or maybe acoustic sensors, or any such sensors, or maybe some other type of sensors. Maybe video camera is also a sensor itself. It is actually sensing the surroundings, right? So there are multiple approaches with which where you can actually make this decision. For example, the computing can happen in the cloud, which is an approach because it is you sense this particular data and then push it to the cloud, and you have cloud computing in an action, and then the decision will be transferred back to the specific devices itself. So if you see, this can be the device can be your phone itself, because that's also an edge device, or it may be in an agricultural automation case. This may be something that your sensors and the pump switch on and switch off kind of drives that you are connected. All these things get connected to cloud. Definitely there will be an on-premise network, and from that on-premise network, this is actually getting connected to a cloud network, where the data flows from here to this cloud through multiple media. Okay, so you can maybe 3G, you can use 4G, or directly some other connectivity means that you are actually pushing it to the cloud. There are a lot of advantages to the cloud computing. If you see a lot of applications that you use and you are, which actually makes your life easier, is because of the cloud computing. There is no doubt into that. But edge computing is making the decisions where it is actually getting sensed itself. That means make the decision closer to the sensors and actuators. For example, let's take the agricultural use case itself. The decision, or the intelligent decision happens near to the edge itself. This specific computing strategy is called edge computing. So we can take a maybe a formal definition of it, maybe as edge computing is the concept of capturing, storing, processing, and analyzing data closer to the location where it is needed. It's a distributed computing thought, where there will be multiple devices and it is actually connected, but the decision happens then and there itself. What is the advantage of making the decision near to your computing? The computing happens near to the edge or the devices where it is sensing itself. What is actually the advantage? If you see, there is a huge advantage in many of the time-critical applications, because there is no latency which is involved in the specific computing. And if your data specific security is an important issue, then edge computing is extensively used. Or else, let's say if the company wants real-time actuations and the control system, definitely this is actually the best option. And why it was actually not used extensively before is definitely the computing itself. Computing was costly. It was so difficult to have an edge computing device which is connected to the sensor itself, which is actually making a decision then and there. So this is what the edge computing means. So it's actually essentially saves the bandwidth. So let's say you have a lot of sensors which is getting connected for a decision making, maybe soil moisture related sensors getting connected in the scenario, in the specific scenario of the agricultural automation. In that particular case, all these particular data is actually has to be taken into the cloud, and then decision has to come. So this kind of particular bandwidth is an advantage. Bandwidth usage is an advantage, also an advantage which you can actually look into with edge computing. Now, what is data-driven intelligence? Because we are trying to connect this intelligent or AI ML methods and it is we want to put it in the edge devices. That's what the edge intelligence means. Now, this data-driven intelligence is an interdisciplinary field which uses actually some of the scientific methods. It uses the AI ML algorithms, and it can be structured or unstructured data, and we have some intelligent inferences out of this specific data. So what you get or what you give to an AI ML model is actually a structure unstructured data, which is actually coming as packets like this. And in this particular algorithm is able to make some interesting inferences. This inference word is very important, which is actually helping us to take some decision, or it is directly making some controls with the inferences that it is making. So this is about the data-driven intelligence. Now, why it is actually evolving so quickly at this point of time? Because of the data availability itself. So if you see, previously we were not interested in saving a lot of data because data science or data-driven methods was not so evolved. There was mathematically, it was actually, it was kind of evolved, but at the same time with the computing, we cannot actually make this mathematical models to a form which is usable at any point of time with the application. So that's one of the reason with this particular computing, specifically on the GPUs that we have and high computing devices that we have, we are able to get this intelligence now deployable. It is not happening in many of the labs, but the applications that you are using is actually getting benefited, or you are getting benefited by the intelligence AI ML algorithms. So if you see the kind of infotainment system that was there in maybe 5 minutes before, and at this point of time, you can see the difference itself, because you have a lot of in an automotive sector itself, where the changes are actually taken but slowly. There also there are a lot of changes that you will be able to see, specifically on the infotainment and the kind of the automation or driver assistance that you are seeing. The one of the important contributor for the specific thing is actually AI ML itself, and that is data-driven intelligence. We are learning from the data and then making the decision, intelligent decision accordingly. So we have discussed about the edge and intelligence. So let's investigate some actual scenarios. Let's start from this specific scenario, because this is automotive and you will be able to easily relate to this. For example, let's say a driver assistance system is actually in place, and if it is actually pushing the data into the cloud and making some decision or making some critical decision according to the processed information, which is actually coming from the specific the cloud connection, you can see that it may be the latency for the specific communication may be in few milliseconds, maybe 20 milliseconds or 30 milliseconds. But if you compare with the speed of that vehicle and add this latency, and also the computation latency, which is the decision making latency, which is happening in the cloud, then you will be able to understand that it may be the decision is happening maybe after a few meters this specific vehicle has moved, which can actually cause real problems. So you might right now you'll be seeing many of the driver assist applications. The decision definitely has to happen inside the vehicle itself, the specific vehicle itself. Maybe the infotainment sessions which is actually giving you an extra, maybe the streaming videos or the streaming, that is not a problem, but a critical application like driver assistance has to be, the decision has to be taken in the car itself. We cannot actually push it to maybe some cloud-based system where the decision is actually making. So think like this. Now we are actually moving towards autonomous driving. So this is not only one specific sensor which is actually looking into one direction, that is towards a front, but a lot of sensors combined. It is actually looking the surrounding, the complete surrounding of this particular vehicle, and you can assume the kind of data that it will be generating. And this high fidelity data, once it is actually getting pushed to a cloud, and in case if we have to reduce the bandwidth, then definitely we have to go with the downsampling. In that particular case, maybe a lot of informations are lost. And this is a time critical decision related application. So we need a reliable system which is actually connected to the sensor itself. This is where the edge intelligence is actually coming, it's becoming very, very important. Or let's take a scenario of the specific quality inspection system in a plant. So you can see in the conveyor belt, one by one, the specific robots are keeping or doing some actions on this particular operations on this particular products which is made here, and it is this product is getting moved from one to another. And if you have a quality inspection or the visual inspection system, then this information, the company will not be interested to pass it on to maybe a secure, unsecured network, even if there is high cyber security related tools are existing. Maybe their compliance or their company strategy itself may not be actually allowing them to actually take this. And also, let's say if something is actually not working, and it is actually interesting for them to have this particular control algorithm next to the drives which is actually there. It's the plant drives which is actually driving. Maybe it's a PLC based application or the solution which where this particular plant operation is getting controlled. They are not interested to put this particular data somewhere else and then get the action coming from there. Okay, so this is actually again time critical application where the decision has to happen there and there itself, and it is also the time latency which is actually will be there is also comparatively very less. And likewise, let's take another process industry where a lot of sensors and actuators are there, and then you can actually see the complexity of solving any of the system. Then you will ask, okay, so that's all right. Now, these were existing before also, right? So what about that? These particular machinery was existing, and how it was actually getting controlled. Yeah, there was actually control which is actually happening. But right now, we are actually have the interest of going into predictive maintenance. That is predicting before any such anomalies which may happen in the coming month, so that I inform my service personnel well in advance without affecting my the plant, the production, and I don't have any inventory crunch also. Without affecting any of these particular things, I do a maintenance well before it is actually failing. Which the failing, if a machinery is failing and it is not able to work, at least a line of this particular machinery is actually failing, it is actually a huge burden for the specific manufacturing plants, whether it is process or discrete industry, the product manufacturing industry. Generally, how it is getting surpassed, how they are actually managed to take away this particular dependencies, having a specific line which is actually less loaded, so that something happens, they can actually deploy this particular personnel to the other line, so that there is no much problem happens to the production. The production, less production means you are reducing your profit itself. It's no management will be interested, right? So we are so how we can actually build these kind of predictive maintenance application? The answer is using the AI ML algorithms. So these intelligent algorithms help us to build these kind of solutions, and it has to sit next to the control where it's the control really happens or the sensing happens. That is what I'm actually talking about. So another application where a specific image recognition based or a pick and place robot which is tracking a specific product, and maybe a selected product will be pick and placed, or it is actually to move to a separate line. This is what this is one of the applications. So where we can deploy definitely classical image processing related application. So, but you think like right now in this way. So let's say if you want to do an object detection algorithm where I want to maybe classify or identify some of the objects which I want in front of my camera, and then I have to identify. what was the effort maybe a few years before? What's the effort right now? It's tremendous difference. Maybe some of you will not be able to relate this that much because you may be starting your career now. But maybe 10 years before, I can see that that specific object recognition problem itself would have been a project where a lot of people working towards, and then deploying will take its own time. But at this point of time, any of you can actually build such a system to identify the specified object that you are interested in, maybe in the matter of maybe few minutes, or maybe a deployment ready application in a few weeks. So this deployment ready in few weeks was actually not in our nearest dreams maybe 10 years before. So that is what I am actually talking about, so that you can build many application in the industry with less amount, so that you will be able to increase the production itself, or production efficiency you are increasing, and you are that's finally you are getting products for lesser price also because of all this automation happening, right? So these are some of the actual scenarios where you can actually see the importance of edge intelligence. So why edge AI? I hope I already looked into some of the specific things, specific points in my previous slide itself. So critical applications where AI solutions for predictive maintenance for machines. This is actually a critical application, or maybe a vehicle, the autonomous vehicle that you are looking into, or maybe maybe a driver assist, which is a very critical application that you can actually look into, where edge AI is very, very important. And another one is actually latency between the data acquisition and decision making. We are not at all happy with the latency which is happening when the sense data is pushed into the cloud, and we get the decision after maybe a few milliseconds. So we want that particular computation happen here itself, so that we surpass this particular latency. And another thing is computing. High computing power is actually available at edge. You can see the onboard computers, right? The Raspberry Pi, or maybe the Google also have a device, and NVIDIA device is also there on onboard computers. It's actually very interesting to see, because the same laptop computer that you were actually using maybe 10 years or 20 years before, 20 years before, 10 years before itself, you will be able to see. Maybe you can see your phone itself is more powerful than maybe many of your laptop computers, which you were actually using 10 years before, right? So you can see the computing is actually, there is a lot of computing is available at lesser cost, so that you can actually deploy intelligence of the computation or inference in the edge itself. And the security and compliance. So security, data security, where everybody is interested in data infringement. That is why the cyber security itself is a very strong field, and all the companies are looking into the cyber security related actions into any of the product, whatever the product lines they are having. So this security, people are taking very seriously nowadays. And when the systems and the controls are getting more and more connected, and this particular field is going to increase, the importance of this is going to increase only. And the complaints, there may be some of the complaints that, for example, let's say a chemical plant is there. You cannot actually have whatever intelligence it is also, you cannot have these specific actions happens from somewhere which is actually not reliable. The connectivity is very, very important. So what if that specific point of time you have to take a critical decision and you don't have the connectivity, your data is actually not reaching your cloud, and so what you are going to do, there should be some backup options should be available. But these backup options are in the worst case, and you don't want to get into this particular backup option specifically on a chemical plant at all. Or maybe the backup option for a critical chemical plant may be a shutdown, where you are going to waste a lot of your resources just like that. Okay, so this is why we are more interested in the edge. So with this, maybe do you have some questions on this particular lines, and you can ask me, or yeah, you'll go to the technology stack where we will going to dig in more into how
Yeah,
and what.
there are a few questions, so let me read out for you. There's a question from Kailash Nath. Kailash is asking AI ML algorithms, which you mentioned. Is it built based on Python libraries, or how it is connected to embedded programming languages like C?
Okay. So this is this I am going to actually talk in the technology stack, but there is no constraint about this specific programming language actually. So for example, let's take an example of a classification or a regression problem. What is there is you have some data and you have some kind of learning algorithm, and you have some kind of complex mathematical expression, which you call as fancy name model. And once you have, which is containing the essence of this particular data, which you want the model to learn. So this learning algorithm is actually enabling that. And once you have the specific model trained, and what you're going to do is you give a new input, which we can call x dash, or maybe input itself, which is in lines with whatever is actually learned by the specific model, and then you get a y cap, which is actually a result. So essentially, you can use any of these programming languages for this AI or ML. So specifically we use Python because it was used extensively. The open source Python language was a lot of libraries was there, and industry and academia started using extensively in implementing these particular algorithms. So it became so easy for everybody, specifically on the industry, to work on Python language itself, so that you can do this specific action in a specific and make it into production. Now, let's and there are ways how we can actually take this particular model into an embedded scenario also. So and if you might have already looked into it, it's a specific model, as I told, is a complex mathematical expression. Any complex mathematical expression, if it actually exists in one specific language, it can be taken into another specific language also. So it's a matter of how we convert and map. So for example, machine learning algorithm, it will be quite easy because you will have a mapping happen, something like this: y equal to ax1 plus bx2, maybe a simple regression example or something like this. Then if you know this a, b, and whatever the parameters, maybe n number of parameters are there, and you know that the specific n parameters you just consider in your embedded, it is actually essentially making this particular ML model into your embedded system. So it's as simple as that. And when it comes to complex models, for example, let's say a specific image processing model, pre-built model, there is a way that you can actually convert into the embedded environment. I will actually talk on that specific thing. So I hope that is clear to you now.
Kailash, does it clarify a question with respect to Python and C? All right, yeah, he says yes. Thank you, Kailash.
Yeah.
Let me take one more question. There are a few questions. Let us take. There is one related question. I think we'll talk about it. Pratisha Lalge, do we use any other programming language apart from Python in ML algorithms?
Okay, so interestingly, C++ is extensively used in our self-driving cars, because this is again, so if you see some of the Python libraries implemented on Python may not be optimized. So optimization of the code is very, very critical in many of the cases. So in that specific case, you use C or C++. That is one option that you have. And if you see maybe the devices which is having where the power consumption is also very important, and definitely that you use C++ language for these particular things. So this is one other language that you can use. But as I told you, there is no constraint about the programming or programming language when it comes to a specific application. But if you see the cutting edge research and the implementations in AI/ML is happening, it is maybe in Python. So if you just focus on your specific application that you want to build and what is that specific thing that you are specifically looking forward to from your contribution. For example, let's say I can just clone a repository and I will be able to show any image processing example in maybe 5 minutes, but there is no contribution from my side on that specific thing. So none of the companies will be interested in you to have that specific skill set of maybe GitHub cloning and showing something, because that is not something that in a company that we do. We build application, we build solutions for our clients. And so whether it is internal or external, this is what essentially we do. And then we get the business out of it. So if you are just cloning something from the Git or getting a repo and then running it, is will not be. And the case also specifically on AI/ML. So I have seen many of the colleagues say that they know AI/ML if they understand maybe some of the basics of Python and maybe some of the libraries like Keras or TensorFlow and basics, and they are able to run the specific code without error in maybe Colab or maybe in a development environment that you have. But do you really think about this, whether that is actually a skill set? Yeah, definitely understanding AI/ML algorithm and understanding Python may be a skill set, but just downloading from somewhere and then running may not be a skill set that you can actually sell yourself, right? And companies want you to work in that application, and deployment ready AI/ML codes we have to build. For that, we need to understand from the requirement side, and you should be able to code in a way that it is production ready. Whatever the coding language that you are actually, for example, let's say you know C and you know the basics of AI/ML, I will take you in my team for if that specific role is actually giving you that. And I will not look into whether some other person will be interested in Python, because I'm actually know that you have you have done a C development, which is very interesting for me. And you know one of the programming language, the other programming language learning may not be a so difficult thing. So this specific constraint is actually not there. But let's say, and the other side, let's say if you see that you say that I know Python and I don't know C++, but I want to specifically look into this the self-driving car team, and I want to join. I will not take you, because everything is happening in C++ optimized code, and just knowing basics of Python will not be interesting for me at that particular time. So it's not, again, concluding on this specific thing, it's not about specific programming language or specific libraries that you use. It's all about how well you are able to use these things and how well you know this one. It's not about one specific thing. Even if you're embedded, you can build your core application on embedded, or if it's C, and you can do it, and Python, you can do it depending on the application that you have. So choose your application wisely, and then build your application or the projects that you are interested in. Okay, yeah. Coming to back, yeah. Is that it? And yeah, okay. So
either fine.
I maybe.
Yeah, I think she already replied. Thank you, sir. So just to add what Mr. Jiddu is telling, right? Basically, programming languages are more like, ways to solve a problem, but you need to look into the specific application and know the nuances. It's not about learning the syntax and knowing that particular library, but how exactly can solve a problem, optimize it, and then make it ready for the customer in a production quality. That's what he's trying to get, which probably we also reiterate multiple times in our courses also. Hope folks who are in Emertxe who are asking this question, you're able to get this relation about it's not about knowing the syntax of the language, but it's about solving the problem and making it usable for the customer, right? That programming language becomes a choice for the project, right? That's what trying to get it. One more question before we move on. So there is a question that is coming up. 1 minute. There's a question from Balaji. Very interesting little question towards you. He's asking, what made you shift into AI field, irrespective of your academic related field? It's more of a career related question, but I take it.
So I have actually not shifted into AI ML or anything. That is one thing, because the design of experiments or the mathematics that you learn or the regression methods that you have learned became what we say more and more usable in my organization, because I was working in the innovation division there at some point of time. So I have to move completely towards the specific area. So before also, I was actually working in the specific related topics like numerical computing as well, numerical computations as well, something I have contributed, and internal open source ventures which I have actually contributed, and this is what I was actually doing. So I didn't actually feel any shift in this particular thing, because if you're strong in mathematics and then there is no, it's not actually difficult to learn a specific language, Python, which was emerging at that time because of the Raspberry Pi and the boards which is actually coming, and then build your application. And it's an important, again, back to which I'm actually, you should not actually stick to any of the programming language. You should be flexible enough to know other languages. I'm very much interested in using Arduino and do the programming in Arduino many of the times when I get time. Nowadays, I don't get much time. And before that, some other controllers, specific and edge controllers, and the specific when we create some demos and all. So this is what, so strong on the algorithm part and your mathematics, then you will be able to, specifically on the research side, I'm saying, so then actually will be able to contribute more in this particular direction. But then another question, follow-up question that you will actually get is whether I need to be a pro in mathematics so that you will you get a AML. So it's not the case. Again, it's there are some works happening in the improvement on this particular learning algorithm, so that you create better and better models. That is one thing. And for different applications, there is no specific model which is actually solves all the applications that we have. So that a lot of works going on, and optimizations related work which actually contributing to the control related thing. So you optimize something and you can create control and all. So but you should understand some of the basic mathematics to build your career on this particular aspect. That is one thing. But yeah, that everyone might have all actually learned. But yeah, if you improve that, and you can actually come toward this particular area, otherwise you can actually go to the application specific area where you specifically on some application that you work. Yeah, that's it.
All right.
I hope.
Is it fine, Balaji? Hope that's clear. Can I get some response from you, Balaji Madhur? Okay, all right, yes, sir. So there have been multiple questions asked from, I could see Mohammed Sahil, Prajwal, and, Sandeep. Let us pause it, I think, because your question more I'm seeing coming from the stack, the programming language, which we kind of jumped a little. So let, Mr. Jiddu cover the question, and then we'll take it up, okay? Please continue, Jiddu.
Yeah, sure. Yeah, that will be actually. So, because I'm actually going to talk on the technologist. Yeah.
Sure. Others in the call are able to connect it with the use cases and the edge computing, AML, started getting some connects. Can I get some responses? Folks in the call? Okay. Yashas, Balaji, Gaurav. Okay. Vivek, Kunal, Meher. Yeah, thanks guys. Thank you very much.
Okay.
Yeah, Ashwin. Yeah, okay. Please proceed, Jiddu.
Yeah, that's and the technology stack. So one important thing before going to how we solve a specific technology-related things in an edge computing is that before starting a specific problem, for example, you're working on again on uh, a specific use case, medical use case, where you want to do a monitoring, the vital parameter monitoring of a patient in a hospital. This is an interesting use case and specific on the edge computing also. What is very important is understand the specific problem statement very well, what is actually required and how you will be able to solve that. And understand one more important thing also, that what is the boundaries in which you will be able to solve this problem, because you will not be able to solve that specific problem statement itself, because patient monitoring was there maybe 20 years before, also now also it is there. So what is that the other people was trying to solve 20 years before, 10 years before? Are they primitive on some of the technologies? No, it is not the case. They were, they were using, or they not solving some of the problem itself. So whenever we do a project, we have this boundary condition in which we try to solve. We put this boundary. This is what we need for that particular project, and also understand the domain a little bit more. So just understanding these particular hardware and software will not actually make a solution. And companies want to make solutions, not these particular codes or software codes. That is not the solution is what actually we are selling. Finally, at least there are service companies also, but end goal of the developer is actually to make a solution, right? And that is why you are getting paid for, and that's why companies are actually interested in you. So you have to understand that specific domain a little bit more, and so that you make a good solution, and you will be able to connect this particular hardware and software towards this, and then you will be able to build something which is quite strong. So the bandwidth, the cost of the application, the kind of sensors that you're going to use, and all these are related. If you have a heavy hardware in place, which is if you feel that, okay, I have a big training hardware in place, I will be able to do some wonders. No, that's not the case. You cannot actually make that. Maybe that we put that specific computing power cost into maybe sensors, so that we will be able to sense your surroundings much better. Maybe that may be more interesting in some of the cases. Why I'm pointing this specifically is we are talking about edge intelligence, where many of the times the computing power is not unlimited. It's a limited computing power, because the cost of the application itself is very important in this particular case. So, for example, let's say if you want to deploy the healthcare application, the patient monitoring application into a scale that is all the patients in that specific, or maybe all the critical patient in that particular hospital. In that case, any of the client will think about the cost and in which they are going to incur for the specific solution, right? So making a viable solution is very, very important. Many of the case you will not be able to get this particular glimpse, because you will be part of that particular project, and from one side you will be making a driver for it, or maybe you are making a user interface for it, or you are making maybe backend codes on this or this, so, or application layer codes on this. But try to understand that, try building that specific insight right now itself, so that you will be able to, and specifically in this particular edge intelligence also. So coming back to our specific technology over the topic. So we have the sensors and definitely actuators. I have not specifically mentioned any of this particular actuators here, but definitely there is actuations also. So for example, an alarm in the case of a patient monitoring system, if the vitals is going out of range, can be something that you can relate to for real actuation. Or maybe something, a gardening system, an autonomy in the gardening system, then maybe watering the plant if the soil moisture, or maybe putting more fertilizers into the watering system, water tank. So depending on the fertilizer content in the soil is deviating. All this can be something that you can actually relate to. And you will have some end devices, because finally we are actually talking about some inferences and making more intelligent. So inferences definitely there, but there should be some control mechanism in place, the classical control mechanism in place, which actually includes drivers and signal conditioning and the signal processing, other kind of signal processing systems, and all these things will be there. This will be handled definitely in any of the, when a sensor or actuator is there, this has to be there. And then there may be an edge server which is actually getting connected. I have indicated this cloud connectivity also. Edge intelligence doesn't mean that we are actually cutting off the cloud completely and then we are actually going in this. Depending on the application, maybe some of the cases you are not putting all the data into the cloud, but at least you may be these inferences that you are making with the relevant, some of the glimpse of the data that you are putting after this particular inference is done. That may be some of the case. For example, a patient monitoring system. Definitely alarm is actually done, but at the same time this particular storage of this vital information is maybe happening to the cloud itself, so that you are not losing any of the data if this particular edge hardware security is failing at a later point of time. Or you may be doing this particular update maybe a hourly or weekly, or maybe a daily as a daily routine also. This is also one method with which you can actually do. But this we depending on the application, we may cut or may not cut this particular line to the cloud. So we will actually look into some kind of hardwares that you can, with which you will be able to realize a edge computing solution, or maybe a project, or what is the softwares and what is the technology stack, and all these things we will actually look into. Now, edge computing hardwares, I think you will be knowing a lot of hardwares that you actually will be able to use. Definitely one famous choice, or the popular choice, will be RPi, Raspberry Pi, which is actually running on the Linux kernel, and you'll be able to run the specific, boot this device with that, and maybe run an edge computing application. Or maybe the NVIDIA devices. There are a lot of NVIDIA devices which is available, which is also in the same, a little bit pricey. If this is actually costing maybe 5.4, it's actually costing around 7,000, 8,000 or something. This is actually costing maybe 10,000 in that particular range. Or if you are interested, there is no doubt you definitely can use an Arduino board also for this particular edge intelligence application. Again, kind of computing. For example, the difference of this and this will be, this is embedded platform which you have, and this is not having, this is definitely a Linux kernel, so that a lot of the libraries that you can actually run in the Python libraries, everything you can use here. Here also you can use, you have an advantage of GPU, which is the graphics card itself will be able to, for example, and take an application where you want to identify, control traffic according to the video feed itself, so that the video is looking into the roads, and then from that you are identifying what is the traffic, and then you are making a decision of switching on and off this particular traffic according to the different side, which is actually dynamically you are changing. It's not static. So in that particular case, you need to look into maybe some device which will be able to handle this image processing. Definitely, these particular hardwares will be able to do the image processing, but a better device will be something which is having a GPU. So depending on the kind of how many pixels is available, what is the streaming data that is available, how many cameras that you want to process, depending on that, you have to make the select hardware. But for and you have Google Corals also, which is actually helping you to implement any of this particular application. But it's not about the fancy hardware or fancy libraries that you're going to use, but what is that you learn from that by implementing that, whether you will be able to replicate similar thing, maybe if I'm giving a different application altogether. So that depends on whether you have understood the complete process of from the developing to the deployment. So again, computing power is important, and computing strategy and the control strategy is important, and sensor required, and scalability and cost. So another thing is, it may not be the case that the control that is happening, for example, let's say you have a microcontroller which is actually controlling a specific or getting data from the sensors and then doing the processing and then doing a control. And you can have an RPI or another microcontroller itself, which is actually doing this specific operation. So all these are architectural choice. There is no one good way of doing all these things. Maybe a PLC will be in action, which is actually will be controlling. Already, it may be a brownfield approach where already there is some PLC based control existing. You are actually introducing a predictive maintenance application on top of it. All these things, it depends on the application again, but yeah, you know what kind of hardware that you can actually look forward to. These are the hardwares, and a lot of interesting projects will be available. Those are people that are Medium post or the YouTube you search, and you'll be able to see a lot of kind of projects on this. But I will take you through one specific route with which you will be able to deploy one specific or build and deploy a specific application, so that you will be quickly able to get a glimpse of how how you can actually do. So once you do with one of the hardware, and again using another hardware will not be a big deal. It's a matter that you change the programming infrastructure, the kind of flashers that you're going to change, and the kind of application, maybe the kind of applications we are looking into, from image to sensors you are changing. Again, I'm not I don't have any hatred towards the NLP applications. There are a lot of NLP applications or the KG based application where the language processing also happens in the edge, and like handwriting recognition system that you're using in your phone will be a wonderful example for an edge computing system which is actually being done. So so this is also important. So I'm not biasing. I want to make sure that your project idea is not biased by the kind of project which I am mentioning, but I just want to give you a guidance on these are some of the projects that you actually can look into. Okay, now coming to the training and inferencing. So if you look into a machine learning model, so I've actually mentioned how you build a model. So training is something, and inferencing is another part. So many of the people get confused with the complexity of a machine learning model by just mentioning training the process. Maybe a model which is actually taking maybe 1 hour or 2 hours, maybe a few hours, which is actually to take train. I can actually make the inferencing engine which I can run in a microcontroller. Definitely, I have to get rid of some of the fat from the specific model. There are approaches to it, and we actually not look into all these approaches at this point of time, because there are a lot of approaches, and it will be an AI class if I'm going into. But there are methods with which, and I will actually tell you one method with which we are how we can actually do it. But the techniques that you can actually use for making this inferencing model small, there are many. So don't get confused with, let's say I have huge data. Huge is also not it's not a quantitative term. I assume that maybe if I have few GBs of image data for training, and can I deploy it on the edge hardware? Yeah, it is possible. Depending on the kind of application, it is actually possible, and there are a lot of examples exist also in this. So don't get biased by these hours of training with your specific application. I have only Arduino, you know what I'm going to do with it. That kind of mindset that you don't have to. Definitely, if you have Arduino Nano, then you cannot build an image processing application also. It is technically possible, but what I'm saying is it will be difficult to build something like that. But there are other Arduino hardwares which is actually supports these kind of things. So identify either if you're constrained with your hardwares, then identify use case which is which can be done using that hardware. Or if you don't have, and in that particular, maybe if you are able to spend maybe 4K on this any of these particular hardwares, RPi or any of the computing, you can actually, there's no limit to it with which you can actually there's no limit for your exploration, because you can essentially do any of these particular, run any of these models on this. Okay, now coming to this specific training itself. We have taken a simple example, the classifier, either cat or dog, or maybe object identification is also a classification problem. So where you have some data set and you have training data set, finally you are getting the train model. So why this specific train inferencing is will take less time? Because the learning process actually, or training the weights of this specific neural network model take a lot of time. But just computing one pass of on this particular complex mathematical equation, you can say that this is a function of x, definitely, because it's a mathematical equation which you can actually represent. Now, one pass on this particular function, many of the cases may not take time. That much of this particular training. So that means if your training time is maybe 6 hours also, maybe that it not even actually takes 6 seconds to run this particular. And if you use the kind of technique which we are going to mention, it will not even take maybe 30 millisecond or less than that also. So there are ways with which you can actually do. Another thing is, another question will be, okay, so let's say I have a model which is actually the TensorFlow, which is one of the famous library that you can actually use for any of this, will be maybe 500 MB. And now the model itself will be 10 MB. Again, how I can actually use this, because my hardware which I'm actually going to use will not support this particular 500 MB into my SD card. But there are ways how you can actually do it. And 10 MB, this also can be reduced to a few KB so that your application can be served with the specific model. Now, the selection of AI algorithm. So I have seen many of the people spend a lot of time on AI algorithm. Definitely, AI algorithm selection is very, very important for a specific application. Now, there are a lot of algorithm which is actually existing, depending on the kind of data that you are using, or kind of complexity that you, or kind of the pure problem statement complexity. Again, here, it's not the case that you use the latest updated deep learning model for your solving the specific problem. Definitely, if you have a model which is running, better one will actually give better results, and you can actually show that. But even if you are using a vanilla LSTM model, a vanilla normal model itself, deep learning, which is multi-layer perceptron model itself, and if you are able to show some results on that, and you are able to showcase that, yeah, these are the pipelines that I have taken so that I have reached this particular stage, we actually evaluate based on that. It's not the case that you get maybe you say that 97% of accuracy, then only you will be able to say that, okay, I have solved that specific problem. It's not the case. Maybe in some of the cases you have very less learning, and maybe 70% or maybe 60% itself will be more than enough for that specific. Again, if you are not expert, maybe the first time when you are doing maybe any of this particular model selection and all, you are not expert, it's perfectly fine. Maybe take one specific, maybe take an example, deep learning model itself, and then understand the end-to-end process. You don't have to be expert in all the domains. Many of the cases, you understand that that specific domain, and then try to implement using the technology that you are expertise on, and try to improve on that side. Maybe it's not an organization is not made by only one person, and we work in teams, and maybe there will be a deep learning expert, and there will be a DevOps expert and cloud expert, and different areas, maybe a solution that specific domain expert also. So combine, we create a solution. It's not the case that you have to be expert on any of this particular areas. That's an important message there. And definitely, once you get interest, explore on some of the other algorithms also, so that you get this depth also. And for a skill set development, which is actually in lines with what we are actually talking, there you can actually increase the breadth of your knowledge and increase the depth of your knowledge also. So optimize on this particular thing. So maybe that you just looking forward to the breadth. You don't have any depth on your knowledge. But you just look into one of the specific technology, you just build only on depth, maybe that you would not be able to understand some of the new technologies or some of the other technologies around your ecosystem or the technology that you're working on. So take an approach where kind of optimize in between. So explore on the technology at the time. You try building your skill set on some of the important technologies that you like. That you like is very important, because otherwise you'll not be able to persist on what you are doing. Okay, now getting a model ready for edge deployment. So first of all, we have to train a learning model. For example, let's say if you take example of an object detection, you may not have to maybe train a model itself. A trained model will be already existing. You just have to use that. That means you just have to pick that specific model, because object detection is not something people started working on yesterday. There are a lot of people who has worked on that, and there are a lot of models available also. So you can just pick that model, convert that so that you can actually deploy in your edge hardware, and then work on optimization. Maybe at the first time you will be running and it's actually not working as you thought. Maybe it's not so fast as you think, or maybe some of the things, and try to optimize, convert that into the specific model. Maybe shrink that particular model. Maybe you have overshrink that specific models, so you don't do that. Maybe try to optimize on this particular aspect also. But basic settings will be available, and all these libraries that you're going to see for all this. So even if you are not configuring any of these things, it will be made into a deployment ready application, and you will be able to start working or start seeing the light at the end of the tunnel. That is, you are seeing that object detection is really working in my edge hardware, or maybe a patient monitoring related problem is actually working on your edge hardware. So try to do in this specific way. As I told you, start with picking a model maybe, and then converting that, and then deploying and optimize. We'll actually, in the sample project, we'll actually look into these specific steps so that we will understand on this. And hello.
Jidu, there was some lag in the video. Are you able to hear me?
Yeah, I'm able to hear you.
Okay, now I think it's fine. There was a folks in the call. Are you able to hear?
I think that in between there was some connection problem from my end, I think. Anyway,
Yeah,
so what I was, yeah, I think,
go ahead.
did I reconnect? Are you able to? Okay, interesting that. Okay, what I will do is maybe if you have some questions, you can ask. By the time I may be able to fix this particular screen sharing issue, I think.
I think it's fine. We are able to hear you clearly. Anyways, let us get into a few questions now. There's a question from Dhrubajyoti Sharma. He's asking, in the focus should be more on towards the technology algorithm use, or focus should be more on the required results?
Okay. Result required. Okay, from a learning perspective, for example, when you are looking into a learning perspective, you can actually focus more on the what from the technology. So results are very important. So that actually motivate to work you on that particular technology, right? It's not only the okay. When you are a fresher, you maybe the salary that your take-home salary will be something that actually will be interesting for you to work and grab your job. But that's not the case when you move ahead. So I trust that initially you can actually bet on the technology, and then results are important when you to keep you motivated to improve on the specific technologies and all. Okay.
All right. Is it clear, Dhrubajyoti?
Yeah.
All right. Yeah. There is one more question here. One second. Couple of questions. One is from Dayanand Dongade. He's asking, I'm currently doing my PhD from SVNIT Surat and just completed coursework. And my interest is to do research work in embedded systems. My question is, can I do the research work on embedded systems based on AI, ML, edge computing? If yes, how to proceed with it?
Yeah, I think there is no problem in selecting that specific topic, and if your guide is allowing you to do on that, that is also very much important in the case of PhD. So if your guide is aligned with that, and definitely that is actually a topic of very much interesting, and so the edge computing and the intelligent systems. Yeah, we can actually do.
So there's a question how to proceed, like how to start.
Okay. So definitely research work. There is a way when we do a corporate research that we start definitely for institutions where the classical research work is actually being done. Definitely have to start with your literature, and then you have to identify your specific problem statement that you understand, that you are looking forward to, because maybe why I tell this specific thing to all my colleagues also is that before starting, maybe that topic is new to you, but may not be new to many of the other people outside world. So you will, if you're before defining the specific problem statement, because this is an area, edge computing, edge intelligence in an area. There are different ways with which you can actually do a research on, maybe optimization technique of the specific models, or maybe a specific computing technique with which you will be able to make the deployment quite easier, or maybe over-the-air updates for some critical systems, and all these things are of very much interest in the domain. But start working specifically before narrowing down to your specific problems. Do a thorough literature survey. You see that what is the research gap, and then try to address that specific research gap. And when you identify a specific research gap, very importantly, when a corporate research that we do is see that whether that research gap is going to get filled in another few months or few years, because there are people who are working on this before also. Right now, as you start working on that, it will take some time to ramp up on this particular topic. So by the time others might have reached some other level, so your works or your problem statements not be obsolete at that point of time. So take a wise decision accordingly. But I think your research guide definitely will be helping you out in this pursuit, these specific things, because that's why they are there and they are very much experienced. Even if it is a new technology, the research, the methodology of research will be quite embedded in their mind, so that they will not miss out any of these points. And yeah, that is something that you can actually look forward to.
All right. Is it fine, Dayanand? Hope that's clear. There is one more question, Jizu, before we move forward. There's a question from Sandeep
Okay.
Verma. Asking, do you suggest me to learn Tiny ML if I'm interested in portable embedded systems?
TinyML is one of the method that you can actually use. Yeah, you can. Again, there is no problem in investing on some specific technology if you are interested in that particular thing. So this also holds good in this specific case. So definitely you can explore on that.
All right, definitely something. One more thing before we move on. So on quick and I think very interesting question coming up. It's from Ashwin. Sir, could you please discuss the mathematical foundation for machine learning? What is the mathematical
Okay.
foundation?
Okay. So this is a very important topic. I think that specific question itself is so important, and the answer is not in maybe one or two lines also. But maybe I will try to maybe squeeze it into a few sentences. Important thing is that your engineering mathematics, if you are actually good at it, it's actually more than enough for you to do any of these particular AI ML courses or but see, understanding the algorithm is one thing and using that is another thing. Without understanding also, you can essentially use it, because these particular algorithms are already available as in the form of some libraries, and so that you will be able to directly use it. That is there. But actually, when you apply a specific mathematical solution into a specific problem statement, an understanding of how it is actually done will actually improve the solution itself. Because you may be assuming some of the things, and you may be, with that assumption, you may be doing this particular actions, and there will be some edge cases. These edge cases are very, very important. For example, if for a critical application, something sometimes is not working. This sometimes something is actually not something that is not acceptable. Or maybe some of the early coders will say this particular saying, right? It was actually working in my system. Uh, that can be solved with the ML, the ops, DevOps, and related things. But I think yeah. But important thing is that uh, um, how you can actually work towards that and get this things solve this. This is very important. So in that direction, the understanding on the algorithm is going to help you. Uh, so so in that, with that specific aspect, again coming back to your specific question, your engineering maths, if you are actually strong, and actually you will not face any problem. You don't have to be quite strong also. You have actually passed on this particular engineering maths. Definitely statistics is important in that particular thing. And if you are good at that, you can actually do it. And there is a perception that, okay, if I was actually not good at math on some point of time in my life, I cannot do it better at this point of time. That is actually a wrong perception. It may be the case that if you relook into these specific concept at this point of time, maybe some of the statistical approaches and all, you will be able to relate that to real scenarios, and you will be able to learn. Maybe a specific language or specific technique or some specific equation that you have learned not in a right way is the main reason that you don't understand it. It's not difficult many of the times, but as you know, it is not a generic case. Many of the cases that is the case. So if you relook into that, relate it with a real problem statement, then actually you will be able to solve that, or you will be able to understand that quickly. Okay, so don't limit your skill set with the perception that you are actually not knowing. This is where many of the people get stuck into. But again, root is use it, understand, see that how it is working, understand what is in the background, and improvise on this particular things. That is the strategy which I suggest to you.
All right. Yeah.
Okay.
Thanks.
I think
Jiddu, we can. Yeah. I think demos, and we're also
yeah,
kind of, Yeah.
yeah. So autonomy and autonomous system. So the final goal that we are actually looking into any of these things is making a complete autonomous system. So what is an autonomous system? A system which will be able to take a decision by itself and take actions for a specific problem statement. We call it as an autonomous system. So this is very important that we build this kind of application so that we get a better out of all these particular technologies that we have discussed on. So I will quickly go into this applications and then maybe into the demo, because otherwise we'll not be able to complete in this particular time frame that we are looking into. So I have mentioned some of the interesting applications throughout my presentation. Maybe because you will be able to, should be able to relate it, all this. So I will actually take you through some of the applications, some specific area, for example, manufacturing, healthcare, and some of the application. It is not limited in this particular thing, because it will be an exhaustive list, as I told you before, if I'm actually looking into multiple areas and then and just keep on discussing on this application. But applications are very important because you have to like that application, otherwise you will not be able to enjoy that particular building process. If you enjoy the building process of your project building process, then actually you will do it quite often, and which will be helpful for you in your career. Okay, so manufacturing, quality inspection is one specific use case, visual quality inspection, and sensor-based quality inspection also. So visual quality inspection, as you know, we look into some product quality related problems by using the cameras, live camera fields, and you take maybe group them or maybe get the reject pieces so that you are not missing out. For example, let's say when we are making an automotive product and one of the part in that specific engine is actually failing, just because of that specific failure of that particular some specific component, that engine fails and it has to go back to the garage when the next day that it is actually sold, which is actually very horrible situation for the customer, also for the dealer also, right? So maybe that one specific alignment problem is actually getting this. There are a lot of ways with which you can actually check this quality, and quality inspections are quite strong now. That's why you will not see many vehicles which is stuck on the road, or it's not moving in the road at some point of time. You will see that comparatively less at this with the, I think, in the specific in this decade than the previous one. You can assume that what all problems that you were actually facing in an automotive or in a car when your previous generation, maybe 10 years before your car, maybe 20 years before also. This, I'm not mentioning some of the OEMs here because I should not go with you, but you can actually assume some of the problems, and it's actually not moving or stuck with some problem, and then you have to take it to the garage or tow it to the garage. Which is very, it's actually a problem is quality inspection. Then now the quality inspection systems are quite strong, and we can actually make it much stronger. And that is one reason is because of the intelligence system, and we can actually make it more stronger also if you make more and more intelligent products. Inventory management and predictive maintenance of the machines and predictive equipment failure. So this predictive maintenance is actually having a lot of scope these days because of the nobody is interested into failing any of the machine on a factory floor. I think we have mentioned this specific example at the start of this presentation itself. So we are more interested on timely maintenance, but not maintenance which is happening on a schedule. Okay, for example, let's say if you are doing, actually, when you are taking your car for a service, you are actually doing maybe this many kilometers or um, hmm, this many months interval. But if you are able to identify what is health of your car, depending on with some intelligent algorithm, maybe just actually listening to your car vibration itself, it's actually an interesting application that with which you will be able to improve the customer experience, right? And maybe OEMs will not be building this because they are what we say, the business also dependent on the customer service, the service also, so they'll be making money on that. But yeah, a startup which is actually working on this will be a very interesting thing, and there are a lot of applications also in this specific line. Okay, now healthcare. So this again, it's very, very important, and a lot of people a lot of companies are investing on this, analyzing test, that is a blood test or any other test, and getting more out of this specific data. So we know that there are some intrinsic patterns that you will be able to find from the this particular test or the scans, or maybe some of the diagnosis devices. But can we get more out of it? Can we get more patterns out of it? This is where AI ML is actually coming into play, and where we will be able to get more insights about some of maybe ECGs, and also that we will be able to identify this. And you can see wearables is an important area where those companies are investing more, and also this is market is going to grow in the coming years, right? Because everybody is more interested in these particular gadgets. So, for example, say a company like Apple was not actually making even a single watch, is now making the best, most profit out of this watch industry, I think. So, because of the wearable that they have, and it's actually competing with the legends in this particular industry. And you can see that this trend is actually going towards that people are more interested in their health and what they how they in their routines or the exercise routine, all these things, these patterns are very important. So right now we can actually listen to your heartbeats, and if variations on the heartbeats can actually will be monitored, and it is actually there prompted for actions also. These things are available at this point of time, but this is just a start of the applications. A lot of things to yet to come on this particular area. So patient health monitoring, I think we have discussed in the specific regard more. And these are some healthcare and self-driving vehicles. As you know, believe me, is the self-driving cars is going to be the future in the mobility. People are now believing that some of the people at least will have the thought process at how it's going to work, and this. But the developments which happened in this particular decade is huge, and we have at least now self-driving cars in some specific areas, where the specific areas, I say specific, general self-driving is actually not available at this point of time also. But driver assistance system, you have seen a lot of advancement. This will eventually get into a mode that complete autonomy on the self-driving vehicles also in the coming years. So what has to be pointed is the job opportunities and your career prospects that you can actually build on this particular areas. So for example, let's say you upskill in this particular area, the perception area, how the vehicle is seeing the surroundings, and how it is actually taking the decision out of this particular surroundings. If you are able to reskill in that particular area, it's very important, and it's very important in the embedded field itself, because finally these decision makings, this critical decision makings, is not something which it's a reliable thing which has to work, right? So it's not the case that we have some probabilistic approach. Definitely there is a probabilistic approach, AML approaches, which is in place, but finally the decision making should be a clear one, or it is not not a biased one, or any of these things. So and optimized codes are very, very important on this particular area, so that you can actually this is something that you can actually look forward to in the coming years, where a lot of opportunities are coming. Now, driver monitoring. Again, this is also a critical application where edge computing actually plays an important role. This kind of systems actually helps in avoiding many of the accidents, right? Because it is quite easy to build some systems which is actually identifying and making alarms on this particular aspect, so that whenever we are distracted, or maybe we are not definitely wearing seatbelt or using this, it's quite easy to now also, there is no intelligence required. It is a proximity sensor that you are connecting, so that you know that whether this person is wearing or not. Maybe that if you have seen maybe somebody's doing something like they don't wear the seatbelt, but the seatbelt proximity sensor is engaged by they keep something on that. These kind of scenarios can be avoided, and it has to be made compulsory on a public interest also. So these kind of systems is very relevant, and the way to do is so it's computing edge intelligence, where in your infotainment system itself is having this kind of driver monitoring system, and they'll be able to take actions on this. Okay, again on agriculture, with the interest of time, I'll not, maybe you will be able to relate with this particular picture itself, what I'm actually talking on autonomous way of controlling this particular agriculture. It's a lot of companies are investing on that, and it's essentially the similar technology that we are lived into. Now, with this, I will go to a demo where I will actually show you how we can actually build an AI model and make it deployable on Edge. So the code is available. By the way, these are codes which is actually from the TensorFlow libraries itself. I have just stitched it together, so you can actually either access it my GitHub profile, or directly from the TensorFlow Lite TensorFlow GitHub page itself. Go to TensorFlow and TensorFlow Lite, and you will be able to look into this. Again, I just use the specific TensorFlow because you will be able to, many of you will be maybe familiar with the specific library, but there are many ways to do this specific edge deployment. So you can actually look into multiple other ways also. But yeah, this is one sample way to approach this particular problem, because these particular libraries and the programming language is quite famous. So we will look into this. So with that, I will switch to the screen. So this is my GitHub page, where you can actually see the specific repository. Go and there are a lot of interesting projects which I have updated and keep on updating. If you would like to follow me, you can do that also, so that you will actually get the updates on the projects and repository and the activities which I'm doing. And another important thing, if you don't have a GitHub profile, go and make one. And now it's not for one specific stream of developers like computer science. So it's a code hosting platform. Any kind of code can be hosted there. So in any organization, you will have a repository-based system, right? You are developing something, whether you are doing a research or innovation or a production or whatever it is, you will have a system with which all your codes and everything is actually handled. So either understand one such, and best way is actually use the kit itself, and so understand. And a collaborative work environment also. So it's not the case that all of the code is developed by you, but you have an accountability of what is actually developed by yourself. So how it has to be handled is using the kit. I hope you are actually you already know this, and so go to the repository. Let's look into it. Okay. Again, what I'm actually using is the specific code you can actually execute in your system, or directly go here and click on the process of how to deploy and how to set up your Raspberry Pi is actually there. So this it's like this. What you're going to do is you have some data. You have some data, and you are going to use some kind of library for training this particular data and creating the library that you're using is here, this TensorFlow, and then you're going to make a specific file, which is actually your model. Okay, this will be an H5 file and .h5. So And after that, what you're going to do is you're going to take this and convert that using the TensorFlow Lite, and then convert this into a format that so that you will be able to use it in your RPy. Okay, so in your RPy, there is setting ups. For example, in this specific case, it is rock paper scissors. You know this particular. All of you might have played this particular game. It's the rock paper scissors. So what we have is an image recognition to understand whether it is your gesture is a rock, paper, or scissor. This is what the data, the problem statement. So now, how you can actually deploy it in RPy is, you know that RPy supports the cameras. You can plug in your webcam or any kind of RPy cameras also there, which is available for, I think, less than I think $600 or something, and you can plug in that, and you will be able to show your hands and get that whether what you have showed is rock, paper, or scissors. So you can build some system. Will that be interesting, where you're just having a box which is having your camera itself, and then you will be able to see that your gesture recognition system is actually working your specific gesture. And object detection examples also, similar thing, or any of the object detection or streaming example, the video streaming examples also, you will be able to make or deploy on RPy with a similar technique. So we will just see one such example. Coming to this one. Okay. Oops. Okay, so what you have to do is launch this particular, for example, this is the IP is the notebook file, and I'm launching Google Colab, where you can actually do this particular coding. By the way, I have used Colab for this specific demo because it's quite, you don't have to set up many things for training the model. So as I showed,
Jiddu, I think we are not able to hear you. Jiddu? Jiddu, we are not able to hear you.
Here.
Hello? Folks in the call, you are able to hear me, right? Can you just confirm if you're able to hear me? Yeah, I am audible. I think some connectivity issue. Jiddu, they're not able to hear you. Just a minute, guys. He's checking, maybe.
Yeah, can you hear me now?
Yeah, you are. Guys, Mr.
Okay.
Hindus, all right, yeah, looks good. Yeah, please proceed.
Okay. So what I can you see my screen now?
Yes, we are able to see the screen.
Okay, that's great. So so the first thing that we are actually doing is import some of the libraries, Python libraries. For example, matplotlib is for plotting and numpy is for numerical computation. TensorFlow is the library that we are going to use, and TensorFlow Hub is the library where you will be able to get the models. So I mentioned you an important thing. You don't have to essentially start from scratch for building any of the models, because already existing image processing related or the object detection related models are existing, and you can actually use that. That is one important thing that you have to remember. You don't have to train it from scratch, and also this particular delta you can actually bring into the first. And definitely, let's say if you want to, for example, let's say rock paper scissors, you want to extend it to some other gestures or maybe some other objects, or all these things you can do. In that particular case, what you do is similar model that you are going to take and then do a transfer learning, that is retrain or that delta specific learning for your specific data set that you are going to build. So that is what the transfer learning is, and you are going to do it here also. What you are doing is you are using the specific mobile net model, and 224 is the pixel, and these are important because again your whatever image that you are actually taking also should be matching with the similar pixels that you have here. So these things are very, very important. Now okay, so uh, you are second step, what you are doing is a model selection. What you are doing is a mobile net model, and there are other built models also. For example, you can actually look into the library and see, identify a couple of options here is inception models is available, because these are the parameters that you can pass to the specific library so that you will be able to identify the specific models. And so in short, we are using a previous built model and training for the new data. So from where you're going to get data, there are some data sets available from out in the internet itself, so that you can use it. TensorFlow data sets is one space where you can actually find some of the data from object detection related data, and all this rock purpose data set is actually available in that TensorFlow data set. So import that specific library, and you define your training and testing splits and all, and then you see that how much you want to use for training and how much you use for testing, all these things. Format the data. That is, the image pixel will be actually, the value will be 0 to 255, and then what we do generally is divide by 255 so that you get a value for each pixel which is actually ranging from 0 to 1, which actually helps for training your model. So than using a value which is actually 0 to a higher value. So, and then there are some batch sizes or all this which is actually related to your training model itself. So if you're entirely new to this, there is no problem that you can actually skip this particular what it is actually doing and all. Eventually, now you look into the deployment, and later you can actually come back and understand each step how it is actually getting done and all. So finally, image batch shape is something this. So each batch is having 32 32 images, which is 224 cross 224, 3 channels. That is what the 3 means here. And next, building a model. So building a model means what you are refining. Define to define. Okay, I think I have forgot running one of the cell here. Just transition matches. Okay. Okay. So what we are doing is we are creating a model with some layers. What we define here is Keras TensorFlow API, Keras API. So with that, we create the model. So which actually represent a mathematical, as I told you, but we have layers on top of it so that we are not actually going into that mathematical step and then writing anything in this particular direction. Then next is training the model. So in this specific thing, what you are actually doing is taking this particular model that you have and training with the new data set, that is rock, paper, scissors data set that you have. So if you look into the data, how it looks like is, so you can navigate to just search for rock, paper, scissors data set and so on, and you will be able to get the specific data set. You can look into what the specific data, so you can see that it contains the different images, which is actually either rock, paper, or scissors related images. I think here everything is rock, and you will be able to select depending on the what all images is there. So there are sources of this specific data, all these things are mentioned. But let's say you have your specific data set, you can actually ingest that also. You just have to line few lines of code and you will be able to do. Now, what you are doing is exporting that specific model. And next, what you have to do is you are saving the specific model. And so once you save once, you don't have to revisit the specific thing because it's already available from here onwards. Now, areas where we are more interested in is what we are going to use is we have to convert that into a TensorFlow Lite model. So for that, what we use is TensorFlow Lite library, and we import the save model what we have here, and then convert that into using a converter, TensorFlow Lite default converter itself. And next, what you have is you take that and see whether it is actually working on an interpreter. So finally, the downsize model what you have, whether it is actually working in your interpreter, you are checking. And if it is actually working, you can go ahead and then download this. Once you download this, the next thing is you take it into the Raspberry Pi and you should be able to deploy that. Now, so here, what we are doing is we are testing on the specific thing and then see that it is whether it is working, for example. So you can see that whether it is, for example, this is scissors, and you will be able to identify that as scissors. So likewise, you can, any of the object detection, any other models also, you can actually build if you change the specific data. Next thing is you need the specific models and you have to download that. So it will be converted files will be downloaded as TF Lite files, and you will be able to use that with your RPi, and then you can build your RPi application. So RPi configuration, I'm actually not going in depth into RPi configuration, how to use the specific things there. But what is available is, this code is available. So in that, you know how actually you can actually deploy it in RPi and then how to use it. Maybe you can try it and then you see, you can actually pause me also how you are actually seeing, and or explore on this particular context and identify a better problem statement and try to work on the specific thing. But I just want to show you that if you build a machine learning or AI model, it's as simple as that. You can actually convert that into a model which you can actually port into another device like Raspberry Pi, or okay, embedded connects is also available. You can try in TF Lite. There is a specific embedded related specific libraries also in the TF Lite modules also available in the TF Lite. We can explore that also. There are some specific Arduino versions which actually supports, and Spark on some of the boards also directly it supports. It is not limiting. You can actually do it for the other hardwares also if you just invest some time on this. So with that, I think we are already 9:05. I'm not extending this specific thing, and specifically to the career opportunity, I think I don't have to specifically mention at this point of time, because all of you know that since if you are able to, since there are a lot of use cases and applications you're going to see in this particular area, a lot of companies working on this particular areas. If you upskill on this, definitely there will be actually advantage on this. So, but you post me what you see, or your career opportunity, anything on this particular lines, you can post me on in my LinkedIn page, or you just message me in LinkedIn, so that we'll be able to interact in that way also. So with that, I stop my presentation. Maybe if there is some questions, I can take that.
All right. So thank you very much, Jiddu. I think that was quite an overwhelming presentation, starting from all the way up from the edge computing, show enough to say a demo, right? There are a few questions, maybe 2 questions we'll take, and then let me summarize, and then we'll go for the quiz. Let me take one question here. From, again, Kailash. Can you do a roadmap for a fresher in embedded system to land up in an AI-related embedded career? What are the specific projects or skills you need for this, and any one-line observation on this? This is some question Kailash asking.
Yeah. So the roadmap that you can actually look forward, I assume that you will be good at embedded system by that time. So you are good at embedded system. What you can do is with this the skill set that you have embedded system, maybe take up some projects, and then you will maybe the edge AI related projects and or edge computing related general projects. And what you can do is once you do your projects, and you will be able to upskill on the specific edge computing or use of this particular edge computing itself, and then use maybe upskill on the understanding on AML techniques also. With that, you will be able to, generally when you get some of the calls from the companies, definitely they will actually take this as an extra skill set that you have apart from this embedded. So definitely they will also be interested to see you in their company if they are working on this particular area. If you see any of the embedded company right now, they are working in this particular direction, either of these particular use cases which all these companies are working on. You can see what they are working on in their home pages. All these big companies or the fairly big companies, they have keep updated their home pages, so that you will be able to see what they are working on. So if you are seeing the similar companies, you can actually tell your HR also on this specific thing. Some of the time they will actually approach you, and otherwise they may not approach also. But if you have project, you have other ways to explore also. For example, there are a lot of coding competitions and all, it's actually getting conducted. And if you're able to show some of these particular projects that you are experienced on apart from this particular embedded, they will definitely consider you on this particular thing. So this is my advice: build on some of the projects, get into the coding, and then try out some embedded course with the intelligence also. So will be interesting. And very important thing, it's your interest is also very important. So it's not because you should get into this field not just because it is having a lot of career opportunities, but your interest is also matching at this point of time. Then that will actually be great. I hope that was helpful.
Is that clarified, Kailash Nath? Okay, thank you, sir. There is one last question. There's a question from Gajhana Self. She's telling, can you say how to kernels for an object detection, particularly for CNN? I think he's to connect for object detection.
Okay. I didn't get that question. Can you repeat that question?
Can you say how to select kernels for object detection.
Okay.
CNN.
Oh, okay, okay. CNN. Okay. One important thing is, let's say, a classical object detection. There are a lot of algorithms already existing, which is actually using some complex architectures, and it is actually proven with a wider range of data set. So generally, your classic object detection algorithm works actually well with that specific architecture which is there. For example, ImageNet on a lot of applications that depends on kind of object detection or maybe object tracking related and or maybe a segmentation problem. Okay, so try to start with that. Already existing models itself will be able to give. You don't have to build your own architectures. Many of the times you can start with that. That is my first advice. But there are some specific applications where you may have to work on these classical models, which is like ImageNet models and all, where you can actually, what you can actually do is start from a object detection or maybe image related models which is already pre-existing, and train your models accordingly according to the specific use case that you have. Go to the papers which is actually addressing the similar problem and try to look into that and then come to. Otherwise, let's say I just don't want to use any of this particular pre-filled model. Better to go with the AutoML, because there are, in generic sense, any of the problem statement, AutoML actually gives for a good starting point where you can actually start optimizing on this. So that is what my specifically that is my specific needs, and specific to that kernel question. Let's say hyperparameter tuning for any of the CNN or any of the deep learning model is actually a difficult task many of the time. But what we do generally is try to do a literature on where the research, cutting edge research stand, because if we are actually looking into that particular problem, there might be somebody who has already looked into that also. Start from there and try to improvise from there. That is how you can actually do these particular hyperparameters, specifically this particular kernel selection, any of these things. Yeah.
All right. So thank you very much, folks. Thank you very much for asking this question. So let me take back the presenter role. Jidu, we'll get into the quiz.
Sure. Yeah.
So thank you very much, guys. Thank you for asking so many interesting questions. I know we're kind of going out of time. So let me share you the quiz. So here is the quiz. It's already live. There's a code that is there. Let me also upload a file in case if you're not able to do that. I uploaded a file in the handout section. Just if you wait for a minute. In the right side, you will see something called handouts. It's getting just uploaded. Yeah, you'll see a file called quiz code in case if you're not able to see my screen. It's already live. Emertxe, if you just go to Emertxe's web Instagram page, just get into here, just click the question. The quiz is already live. So let me refresh. Otherwise, just saw that it went live. Yeah, quiz is. Yeah, you can see quiz is live. People can take it, and we will always take some time and send you the certificates and for all the participants, and also we will evaluate the quiz and then share you the winners. Winners will get the results and announcement also. We will do it in the Instagram itself. We'll keep it live. We'll keep it live at least till another day. Tomorrow, today is Saturday. That is another day for this quiz to be answered. Okay. So hope a good number of you will be able to take this quiz and also share, or ensure that you learn well. And as always, this is it's an email ID which you can reach out to us. edtech_events_manager@emertxe.com. There's a phone number there. In case if you have any queries, suggestions, any feedback, you can reach out to us in this, especially for people who are joined from outside. Anyways, Emertxe students and interns know how to reach out to us. Okay, that's more of the thing. And like in the always in the spirit of Emertxe, can you tell me what did you learn today? How was the session? Can I get some feedback? How did you find the session? I know it's quite a large elephant. Did you try to put into some packet, starting from edge computing, then use cases into various industries. Then you come to about the embedded connect in terms of sensors and actuators, and how it makes sense with respect to various hardware choices we need to make. And most importantly, which we keep discussing, is about the skill building, where things like, for example, foundational skills. Do not go with respect to any programming language. Often, as entry-level engineers, we get fascinated about programming languages. Focus on the foundations, focus on the optimization techniques and problem-solving aspect of it. And one more very important thing I learned was, if you're good in the engineering, mathematics, whatever you studied so far, you should be able to build, right? And you need to know how to apply those mathematics, whatever you learned, right? That's another learning I had. And very important thing which we discussed a couple of days back, you saw everything was demonstrating from the GitHub, right? In case if you're not built a profile, GitHub profile, please go and build it, right? It's as good as your Aadhaar card as you move forward, right? For a developer, it will become an Aadhaar card, any GitHub profile. Please do that. And somebody asked, how do I transition? Again, if you see his answer, right? Build projects. And even the data that is shown, the stone, pepper, scissors, which we keep playing in our school days, right? So he said, build as a project. Data set is available, and then the libraries are available. Go and build a project, so that you can, showcase to an employer, right? So that's what you do. And last part is that every embedded company is working on this, AIML, because they see that. I keep telling an example of NVIDIA, which Jiddu also quoted in his talk today, right? Every company cannot ignore this particular thing going forward, because it's all getting integrated. You saw, right, how the sensors and the whole edge computing paradigm is getting integrated, right? So that was my learning, whatever I noted. Any other input, any other feedback? I could see a lot of positive feedback coming here. It's amazing. Thanks for the wonderful section. The session was awesome and more helpful to us. Thanks for giving this, says Kirtana. Insightful, since I'm a fresher, in the same insight was helpful, says Muhammad Sahil. Session is nice. Automatic decision making concept is great, says Meher. Very good session, was able to get more clarity on Edge ML, says Ashwin. It would be better if you can send the recorded session. Yes, it will reach you. This session is getting recorded. All the participants will get the certificate. People who taken the quiz, we'll announce the winners sometime next week, and our team will reach out to you to ship the goodies to you. And many more feedbacks are coming in. Very wonderful, covers multiple topics, says Vaishnavi. Nice productive session, says Sham. Very interesting, says Nishad. Very too good a session, says Sai. Helpful and clarity on this topic, says Shashmita. Perfect session, was so helpful, says Diana. It is really helpful, says Sonal. Very good session, says Kamalesh. Sir, entry code for quiz. Anyways, it's there. I think the slide has just jumbled up. You can see there, right? That's a quiz code. Anyways, I'm flashing once again. And I learned how to draft a model. Thank you so much for the wonderful opportunity, says Gajana Selvi. Very informative session, says Ayush. Interesting career path explained in a very easy way, says Yashas. What's the deadline for a quiz? As I told, we'll keep it open till tomorrow, okay, throughout Sunday. Okay. Informative, says Francis. Great session from a real scenario perspective, says Bidu Burman. A bright in the direction of AIML. Yes, it is, says Sanjeev. Thanks for the knowledge that was shared, says Sean D'Souza. It's helpful to all of us, says Sankit Banuse, right? So thank you very much, guys. Hope this was a very useful session. Yes, as I said, this session is getting recorded. Give us some time. Our team will integrate. They will share you the slide deck. Mr. Jiddu has shared in today's session, and the quiz winners, everything will get announced in the next week. Okay. So until we next webinar, keep learning, as Jidu said, the last point, you should have the interest in the domain, right? No matter, don't follow just because it's a fad or it looks like a buzzword, right? Have a passion, build projects, be sound on your fundamentals, right? So definitely there is no reason why you can't have, a career in this particular domain. Okay. So thank you very much, Jidu, for your time and building all the way from the edge computing to showing a demo, very simple, stone paper scissor, which all of us can relate to. So thank you for your time. It means a lot for us in Emertxe and also all the students and interns, who are building the big picture. As I told, 2 M's, right? The mentoring and motivation is what you got. Do you agree with me, guys? All of us are motivated by attending this session, by this mentoring what Jidu has shared. Mr. Jidu, yes, you can see so many S's coming here. Okay, so
Okay.
Sanjay, right? They're all very much excited. How very happy to a lot of feedback. Okay, that's it. There's a question from Prashmita. Please bring more such sessions. Yes, we do. Okay, watch out for the next one. Right? So hopefully we'll do it. Next one we'll do it in. Right, try to do once a month. If possible, we'll bring it. And right. So thank you very much, guys. I know Saturday night is
Okay.
we've been stayed up for more than 2.5 hours, right? So thank you, Jidu. Thank you all the students.
Yeah.
Thank you, newbies, right? Material to reach you.
Yeah.
So thank you very much for your time.
Yeah. Thank you very much, guys. I have also enjoyed the session. Thanks. Bye-bye.
Yeah. Take care. Bye.